Hi again. So this is lesson 2 or notes 2 from the Unit 3 packet. We are on page 4. It is, when I'm filming this, it is December 1st, and my elf came today and he probably dropped like 100 balloons in my dining room. Now I have a lot to clean up. I'm not sure if you guys have elves, but our elf is a little mischievous, like in a good way though. So today we're going to talk about comparing functions, which is something we're not unfamiliar with. But now in this lesson, we're going to complete our vocabulary. So it's a lot easier to talk about things, for me anyway, because now we'll have all of the vocab necessary. So when we compare functions, we are going to look at their properties such as slope or rate of change. So at this point, I know I've been saying this in class a lot, but now formally I am telling you that you can use the word slope or you can use rate of change. They're the same thing. So in lesson 1, we talked about, okay, is this relation a function? And now what we did is we kind of, all this stuff that's not a function, we're just going to put to the side. And right now we're just going to take and study all of the things that are functions. So the first thing is to talk about comparing their slopes or rate of change. So to find the rate of change, use the slope formula. So we discussed that in Unit 2. Some of you use this method. Some of you just use the change in y over the change in x by picking 2 points and making a data table. And you can also, if you're given a graph, you can compare the ratio of the rise to the run. So we'll talk about all 4 methods right now, or all 4 ways that you can present data and the way in which we can find the slope or rate of change. So the first way we can give you a story is if we give it to an equation. So let's pretend this is the lemonade stand. We're back. Lemonade. So this would mean that the girls started out with $9 in their cash drawer and that they are charging, this would come out to be 0.4 as a decimal, they are charging 40 cents per cup, or however you wanted to interpret that. So the rate of change is, we're going to keep it as a fraction, 2/5. This could also mean that maybe it's starting out at 9 degrees and it's changing 2 degrees every 5 hours. So whatever story you want to make works, right? But the slope is always found, or the rate of change is always found in front of the variable x or in front of your independent variable. The next one is they're giving you 2 points. So you could use your slope formula and do y2 minus y1. And on the bottom, do x2 minus x1. Or we could make our handy dandy data table. Oh, say that again. Handy dandy data table. 5, 7.5, and 6, 9. So your change in y or your change in x. So the change in y, you go from 7.5 to 9. So that is an increase of, if you have to get out your calculator and you don't know what this is, you're trying to find the difference between these two numbers. You're just going to do 9, oh, it would be nice if this is on, 9 minus 7.5, and it will tell you the change is 1.5. So in case you're struggling with the decimal. But going from 7 to 9 is an increase. So 7.5 up 1.5. So that's your change in y. And your x values go up by 1. So you can either list the rate of change as 1.5 over 1, or you can just, when you give your answer, call it 1.5. Okay. Number 3. So this is like review, right? We're just using a new term. Rate of change I've only used in class as a way to just get you familiar, but we've never actually put it down in notes. So when I say rate of change, you're using the same exact method as you used to find the slope. So in this case, you're going to pick 2 points. All of these points contain negatives, so it doesn't really matter which one I pick, right? So I'm going to pick these 2. And you're doing the change in y over the change in x, but you have to be very careful when the data table's horizontal. So here are your y values. So you have to start down here. -5 to -11. Now picture that vertical number line I have. If you go from -5 to -11, you're going down 6. You're decreasing by 6, right? And then the x values are going from 5 positive 5 to positive 7, so it's increasing by 2. So the rate of change is negative 6 over 2. You could be dropping 2 degrees or 6 degrees every 2 hours, or you could just say negative 3. You're dropping 3 degrees every hour. So you can either put your answer as negative 6 over 2, but, we prefer to simplify it. And so your rate of change or your slope came out to be negative 3. Rate of change from a graph. So if you look at your graph, the scale is going up by 1. This is a great graph to use rise over run. So you pick 2 points. How about this point and this point, right? And this is vertical change, or the change in y. The vertical change is 1. And the horizontal change is 1, 2, 3, 4. And the slope, so if you go starting over here, if you go this way, your slope is going up, or your line is going up. It's a positive slope. So positive 1/4. Or you can choose to pick 2 points. So 0, 1 and 4, 2. And you can do your change in y over change in x this way, 1 over 4. And you get the same answer. Rate of change or the slope is 1/4. Okay. One word problem and then I'll be done. I'm going to try to go quick. So you have Ty, and he sells signs in a monthly craft fair. He can make 7 signs every 2 hours. Go Ty. His friend Harrison, I love that name, helps him make signs. And the rate at which Harrison makes the signs is in the table below. Who is making signs at a greater rate? Well, you got Ty here, and he is making signs at a rate of, let's do signs over hours. So 7 over 2. So, and look at, this is your x, and this is your y. So signs over hours. And Harrison is making them, now how many, if you're going to find the rate, how many points do we need to pick? 2. And I know in this particular case, you don't necessarily have to, but if we always choose to pick 2 points, you don't have to worry about what to do when, and I just think that makes everything easier. So the change in y is 15, and the change in x is 4. So he's making 15 signs every 4 hours. So this is a little hard to compare, so you might want to take your calculator and figure out how many signs they can make in 1 hour. So unit rate, or just divide. So what is 7 divided by 2? 7 divided by 2 is 3.5. So he's making 3.5 signs every hour, right? And Harrison is 15, top number divided by bottom, divided by 4 is 3 3/4, or 3.75. So Harrison is making the signs at a greater rate because his slope has the greater absolute value, or he's got the bigger number here. So who is making the signs at a greater rate? Harrison is making signs at a greater rate. His rate of change is 3.75 compared to Ty's, who is 3.5. Or you can say 3.75 is big. Oh, man. You can say 3.75 is larger than 3.5. So Harrison is making signs. I wrote through the slide. I'm sorry. Harrison is making signs at a greater rate. His rate of change is 3.75 compared to Ty's, who is 3.5. So you kind of have to restate what you did over here in some capacity. You know how math does that. After 12 hours, what would be the difference in the number of signs that each friend has made? Well, Ty has an equation of y equals 3.5 times the number of hours, and then the y-intercept for Ty is 0. And for Harrison, he is y equals 3.75 times x and y-intercept. If he hasn't worked at all, he's not going to make any signs, right? So what you're going to do is you're going to plug in for 12 hours. 3.5 times 12, y equals 3.75 times 12. And you're going to do 3.5 times 12, 42. So in 12 hours, he makes 42 signs. And in 12 hours, 45 signs. So what's the question? What would be the difference in the number of signs that each friend made? Well, what's the difference between 42 and 45? There would be a difference of 3 signs. There would be a difference. Oh, there goes. Of 3 signs. Okay, I'm going to go. Try your exit ticket. I'm sorry if this was a little lackluster today, but we'll spice it up in class, okay? All right, I hope you have a really great day, and I will see you soon. Bye.